So whereas yesterday or last week we were dealing with triangles and different relationships there and polygons, today we're going into quadrilaterals and classifying them. So it says list and sketch the quadrilaterals with special names. Use appropriate markings from page 91. That's actually, you have those quadrilaterals on the sheet you picked up on the way in. If you want to reference page 91, you can. But I think you're going to be okay with the sheet you picked up on the way in. So we'll go through those. And then the flow chart on page 92, that's actually the sheet. Okay? So I'll let you get your learning goals down there, and then we'll go through those. Let's talk about these different quadrilaterals. So this diagram right here kind of goes through all the different quadrilaterals. It's on page 92. But it classifies them. So if you think of the umbrella of quadrilateral means how many sides? 4. Yeah, if we didn't know that, we'd count hopefully here. Okay, so when you start thinking of the classification, you have quadrilateral, and you start thinking of parallel sides because that kind of helps us out there. So if it doesn't have any parallel sides, it could be two different types. It could be called a scalene quadrilateral, which we know scalene means no sides are equal. So if you want to think of it that way, that's a scalene quadrilateral. Okay, or no pairs of parallel sides could be a kite. Now a kite is unique because, according to these markings, tell your neighbor what a kite is. Okay, volunteer, what is a kite? Really? Emily? Good. A quadrilateral where two adjacent sides are congruent. It has two sets of adjacent sides congruent. So it's a quadrilateral with two sets of adjacent sides congruent. Okay? That is a kite. Okay? It has no parallel sides, two sets of adjacent sides congruent. A trapezoid, we drop down to one pair of parallel sides. So if you have a quadrilateral with one pair of parallel sides congruent, or one pair of parallel sides, you have a trapezoid. Now you can get more specific and go, well, it has parallel sides, and really we would like to see these markings on there for parallel. Right, so you may have to add those to your diagram. But one pair of parallel sides, that's a trapezoid. If we get more specific, we have a quadrilateral with one pair of parallel sides congruent, or one pair of parallel sides and legs congruent, or congruent legs. We call that an isosceles trapezoid. So we have these markings here showing that we have a trapezoid and we have congruent legs. So we call that isosceles. Now most students, when they think of trapezoid, they think of this. Okay, but they're not all like that. Okay, you could have a non-isosceles trapezoid. And then we go from quadrilateral, we could have two pairs of parallel sides. Okay, well, if this is parallel to that, and so I'll put two arrows there, and that's parallel to that, notice I just put one arrow, okay, we have a parallelogram. And then from a parallelogram, we can get more specific. We could say, well, if all angles of our parallelogram are right angles, we now have a rectangle. So note that a rectangle is a quadrilateral. It's also a parallelogram. It's also a rectangle. It has four right angles. So the most specific name we can get for this shape right here is a rectangle. But it encompasses quadrilateral and parallelogram as well. Same thing with rhombus. Okay, rhombus is a quadrilateral. That's a parallelogram. But a rhombus has all congruent sides. Okay, so a rhombus is quadrilateral, it's a parallelogram. Is it a rectangle? I would say, yep, rhombus is a rectangle. No? Is a rhombus a rectangle? Thumbs up, thumb down. Yes? No? The answer is no, it's not a rectangle. Why is it not a rectangle? Tell your neighbor. Okay, is there any rhombus that could be considered a rectangle? If there is, Please tell your neighbor what it would be. Any rhombus that can be considered a rectangle.
Square would be a rhombus, but a rhombus can't be a square. Wait, a square would be a rhombus. A square can't be a rectangle. I mean, a rectangle can't be a square.
Some of you are talking about it. Some of you aren't talking. You got to find new neighbors, Siphi.
Can't find a new neighbor.
Okay, wrap it up. Is there any rhombus that can be considered a rectangle? Volunteer. Maggie, what do you think? A regular rhombus, yeah, have all right, or has all angles and all sides congruent. Yep. So what do we call that? Logan? Square. This square right here. A square. Notice how our flow chart goes here. A square is a rhombus because it has all equal sides. It's also a rectangle because it has 4 right angles. So as Maggie said, it's a regular quadrilateral, which we give a special name, a square. Okay, that's parallel to that. That is parallel to that. Okay, this is a square. It falls under all of this, so it can be considered a quadrilateral. It could be considered a parallelogram, a rectangle, a rhombus. That's what a square is. It has all those names. Okay, the most specific name is square. Are all rectangles squares? Talk about it. So are all rectangles square? No, why not?
Like
Good. All sides don't have to be equal in a rectangle, just opposite sides. So that one's congruent to that. That one's congruent to that. They don't have to be. Are all squares rectangles? Are all squares rectangles? Remember, the definition of a rectangle has to have 2 things. What are they? Opposite sides congruent and parallel, as well as 4 right angles. Does a square always have opposite sides congruent and parallel? Yep, and it always has 4 right angles. Okay, I want to try some problems together here. Turn your sheet over. All right. So, this is off your assignment today, but I've kind of blown it up and made it a little bigger for you to use here. Example 2 says determine the most precise name for the quadrilateral. And I want to start with number 11. Now, when you're given this, unless it says based on looks, determine the most, okay, the most precise name. Unless it says that, you have to actually do some calculations here. So it doesn't say based on looks. Now, if I look at this, what does it look like? Trapezoid. Okay, and yeah, Rory says isosceles trapezoid. Now, that might be true, but we have to be able to show that. Okay? How can you show that it's a trapezoid? Let's start with that. Talk with your neighbors. Go ahead and explain how you can show it. Hey, here's some good things. Let me kind of throw out what I've heard there. Got to find the distance of these lines using the distance formula. I heard that. Got to find the slope of these 2 lines. See if they're parallel. I heard that. Now, how many of you found the distance of these? How many figured out they were congruent in some way? Okay. How many of you found the slope of these lines? What is the slope of line PQ? So you go change in y over change in x. So change in y is what? 0, right? So your rise, in other words, is 0. Well, if you have a rise of 0, what's your slope? 0. This has a slope of 0. So m equals 0 here. Remember, m stands for slope. Well, what's the slope of this? It's also 0, right? We have a rise of 0 again. It's a flat line. A flat line has a slope of 0. So because PQ and RS have a slope of 0, okay, PQ and RS have a slope of 0, meaning PQ is parallel to RS. And we can use this. That little sign, does anyone know what that little triangle means in math? Yeah, that's not changed. No, that's a delta. That's kind of a thicker triangle. Yeah, but that looks like this. This is a delta. Anyone know what that triangle, 3 dots, means? Therefore, PQ is parallel to RS. Therefore, PQ is parallel to RS. These are parallel. So we've shown that. Now I'm trying to get you ready for proof. They're not asking you to do all this right now. I'm trying to get you ready for some coordinate proofs later on. So I'm trying to build your understanding. Now, how many of you found those were parallel? How many just looked at them and you go, I know they're parallel? Okay. Any lines parallel in that one? Yeah? Have you already calculated it, Maggie? Okay, so Maggie's tried to calculate it. There looks like there's some parallel, right? It's not as cut and dry as this, right? So you'd actually have to do some calculations for this one. Okay? Which we'll do here in a minute. But what was our distance here? How many use that big formula? Distance equals square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. I'm so excited to use that formula. How many use that formula? Anyone draw triangles to find the distance? Okay, I want everyone to find the distance right now of these lines, of our legs. Back up here. Hey, probably a poor job on my part. What shape do we know for sure it is right now based on slope? Trapezoid. Right now, based on slope, we automatically know it's a trapezoid. So by finding the distance of PR and QS, what are we trying to figure out? Yeah, trying to figure out if it's isosceles or not. So I have 2 different methods. Okay, I have the distance formula. This one's Diamond's, right? Okay, so Diamond did hers here, and it's kind of a representation of what a chunk of you were doing as I was walking around. Diamond did a pretty good job at showing her work here. She's got her 5 and her 4 here, so her x2 and x1 and y2 and y1. Okay, and she's put them all in here, so she ends up with D. Sorry, Diamond, I'm writing on yours. Equals root 5. Now we talked about it back there. How many got root 5? Okay, so that's using the distance formula, right? Using our formula there. How many use distance? Okay, here's the other one I have. Okay, this one right here is Carson's. Okay, and Carson has used triangles, right? This is the other way I saw some of you doing it. And I saw the triangles drawn different ways. Carson's decided to drop it this way, so he now has a right triangle. He's using the Pythagorean theorem, right? A squared, which is 4, plus b squared, which is 1, is equal to c squared. Well, 4 plus 1 is 5, so that makes this root 5. Okay, he's used the Pythagorean theorem, which is really the distance formula. How many did that way? Okay, good. Either way works. Is this root 5 over here? Yeah, well, that's what we had on this one, right? So I used that one for Diamond. Okay, root 5, and Carson's got root 5 here. So what type of shape is this? Yeah, this is isosceles trapezoid. Now, some of us knew that right away by looking at it, but we've got to be able to show it. Any questions there? We're able to show it because since we know that PR and QS, well, we could just say measure root 5. Therefore, PR is congruent to QS. All right. Okay, so remember, now as we start working through number 12, you want to make sure that you're trying to go through the same process. Look for parallel sides. Look for common lengths. Okay? All right, let's check it out. Now, I know some of you like to use the distance formula. I like to draw the triangles. Okay? Either way works. So if I'm trying to find this side, we get 1. That's a length of 1. This is a length of 2. Okay, so 1 squared is 1. 2 squared is 4. And so really what I'm doing is a squared plus b squared equals c squared. So this is our c, right? So 1 squared plus 2 squared. That's what I'm putting in these circles here. So I'll do that a lot this year. And that equals c squared. So in this case, that is 5, right? So c squared has to equal 5. What's c? Yeah, it's root 5. Okay, so we solve that. We get c equals root 5. Okay, how many got root 5 there? Okay, that's the length, right? Now, really, none of these lengths look the same. We definitely know that, like, when we start looking at slope, we shouldn't have to do the calculation. If I know that's 2 and that's 2, there's no way that that's going to give me the same thing as this because these lengths are different. Okay, same thing here. When I start looking at the slope, I start going, well, I'm going from 3 to 7. That gives me a length of 4, and then going from -4 and 2, that's 2. Okay, that's not going to be the same. And then the same thing here. If I go this route, I end up with a length of 1 and a length of, from 3 to 7 is 4. None of those are the same, right? Okay, is the slope the same in any of them? What'd you get, Grace? Good. So now that we've looked for distance, none of the distances are the same, but the slope, this rise is 1, this run is 2. So that gives me a slope of 1 over 2. And then when I look at this slope, this rise, that's a, well, if I look at it this way, I'm going down 2 and over 4, but the line's increasing from left to right. So this is a 2 over 4, which happens to actually be 1/2. Okay, so what does that tell us about these two sides? Good. Yeah, they're parallel. That's parallel to that. Now you could have also used the slope formula, right? You have a picture, rise and run's easy, but you could use your slope formula if you wanted to. How many use the slope formula? Now remember, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if you wanted to just plug those coordinates in, you could have found the slope that way. But either way, the slope is equal to 1/2 this way. Okay, what type of shape is this? It's a trapezoid. All right. Okay. Any questions? All right, I just gave you all grid paper. Okay, what I want you to do on that graph paper, now it doesn't look like my graph paper because I actually have the grid on there, but draw an XY axis. You're going to need to have room for 4 of these today. So this is one of the 4. All right, so you'll need to be able to do 3 more. So if you just fold your paper in half, you'll have 4 spots, 1 on each side. Okay? I want you to go ahead and plot those points on your graph paper once you get it done there, and then determine the most precise name based on the points you plotted. No one wants to volunteer their paper? Diamond's already volunteered it. No one. Not that I don't want you. All right, anyone else?
I put A on there wrong.
That's okay. It gives me a chance to teach. You want to fix that?
No, I just read it wrong.
Here, I'll let you. All right. All right. Diamond, do you mind if I write on it?
Yeah, go ahead.
I can scribble all over it.
Yeah.
Cross things out. Oh, okay, just show. All right, so, hey, here's our shape. Diamond's volunteered her paper. Oh, sorry. There you go. How many got a shape that looks like that? What's the name of this point? Everyone. Still frozen? Unbelievable. What's the name of this point? A. That makes it tough if I have it frozen. How about this one? B. How about this one?
C.
Aha, D. This one is C. Good. So on this one, what shape is that? Diamond says rectangle. Everyone agree it's a rectangle? How do you know that this side is parallel to that side? Logan? You put a little triangle on the side of it?
Well, like when you connect the two points, making a right triangle.
Did you do that on yours? Can I use yours?
Sure.
Oh, man. Diamond, I wrote on yours. Thank you for starting us out there. Logan was just waiting for me to ask. Wow, Logan's drawn a square completely around his. Check it out. How many have a picture like that? Oh, nice. Okay. So if I'm looking at this, I'll focus it in there. That didn't focus at all. There we go. Logan's got a square. Okay, so Logan, explain to me how that helps us.
Because when you put the square around it and then measure out the sides of the right triangles, you get two parallel sides on each side.
Okay, so this side right here has to be parallel to that one. Right, they both have a slope of what? 1/2. That has a slope of 1/2. We rise 1, we run 2. And this one has a slope of 1/2. You rise 1, you run 2. Good. So in this one right here, this one has a slope of rise. It's actually going down, but it's -4 over 3. And here? The -4/3? Yeah, so our slopes are the same, so we have parallel sides. All right, but that doesn't mean it's a rectangle. How do I prove it's a rectangle? What shape do I for sure have? Right now it's a parallelogram. What do I have to have for it to be a rectangle? Emily? All 90-degree angles, right. Hey, that's right. All right. Haley, do I have all right angles? Okay. What do you guys know about slope and right angles? Think back to last week. We talked about it. Talked about it in algebra. What do we know about the slope and right angles or perpendicular lines? Uh-oh. Look back in your notes. Yeah, Emily, what do you got? Okay, and Bethany, how do we know if they're perpendicular?
If the slopes are like
Negative and like flip it, you know? I do know. Does everyone else know? What's that called? So like AB and CD have a slope of 1/2. How about, so that means this is 1/2 and this is 1/2. What's AD and BC? What is it? Is it -2? We need it to be -2, right? If it's parallel, or if it's perpendicular, excuse me. Yeah, we'd have to flip it and have to be the negative reciprocal. What is it? Yeah, we go down 4 and over 3. Okay, the slope of that is -4/3. Are they perpendicular? No. You guys remember last week we also talked that if you multiply these two numbers together, what should you get for perpendicular lines? -1. We don't get -1 there. Those are not perpendicular. So what do we call ABCD? The most specific we can get is parallelogram. That's it. That is a parallelogram. We've shown it using our math there. Okay. Once again, trying to get you kind of pre-steps for coordinate proofs, not that you have to do those yet. Any questions there? How many drank their coffee?